In this video, I'm going to show you how to use StatCrunch to do simple linear regression. The file I'm going to use is Excel 2023. And what I'm going to do is we're going to go under Stat, and we are going to do regression simple linear. For the X variable, I'm going to select the percent of children in poverty in 2010. And for the Y variable, I'm going to pick the teen birth rate in 2019. Teen birth rate is the births per 1,000 females aged 15 to 19. So it's really not a percent, but we'll just refer to it as teen birth rate. And the other thing we're going to check is we want to save the residuals, and then we're going to compute. So there's a lot of information in this table. We're only interested in a small part of that. Here is the simple linear regression equation. There is a point at which they are going to ask us to interpret the slope and what is the slope. So the slope is the number multiplying the X variable or the predictor variable, which is percent children in poverty. So the slope is a 0.934. And let's see, the correlation coefficient is a 0.78, and R squared, which is the square of R, that R in the output really should be a little r. Correlation coefficient, the symbol is a little r. R squared, which is also called the coefficient of determination, it is 0.616. We care about those numbers, and those are really the only numbers that we do care about on this particular output. If we look at the scatter diagram, I would call that a moderate positive relationship. Let's go back to the correlation coefficient. It was a 0.78. That's not that close to positive 1, which is a perfect correlation, and it's certainly not close to 0, which is no correlation. So I would call this a moderate positive association between the percent poverty, children in poverty, and the teen birth rate. You're going to be asked to copy and paste that into your assignment document. So we're going to X out of this, and we're going to take a peek at the residuals. And I believe the assignment asked you for the most negative residual. So we are going to sort the table in ascending order. So there is the most negative residual. The value of that residual is a minus 6.3. And we're going to, and if you were to round that, it's a 1. And if we were to cursor over to see which state that corresponded to, it corresponded to New York, which happens to be in the Northeast. Just for fun, let's look at the most positive residual. Oh, we've got to get back to the residuals. What is the most positive residual? It is an 8.34. And which state does that correspond to? That corresponds to Alaska. All right, so let's talk about a few things. Let's talk about the slope. The slope was minus 0.34, not minus 9.34. So let me pull up a document here, and why don't we just open any document and request a blank document. So home. Oh, let's see. That's not what I want to do. Let's go into Word and let's open my notes on exam 1 document, and we should be in the Word situation. We should be able to open a new document. So in this new document, I'm just going to make some comments here. I'm going to comment that the slope is a 0.934, and it's going to be the change in y, which is going to be the change it's going to be the change in the birth rate, teen birth rate. Divided by the percent of children in poverty. And it's approximately the same number of years. One was 2019, the other was 2020. So the years we're comparing are close. So that's a 0.934. So the teen birth rate, for every 1% change in okay, I didn't hit return. When the percent children in poverty increases by 1%. My goodness. Let's make it even better. For every unit increase in the denominator. When the denominator goes up by 1, the y variable, the teen birth rate, that should have said, will increase by 0.934. Doing a really bad job here. So let's read it back. For every unit increase in the x variable, which is the percent of children in poverty, the y variable, the teen birth rate, will increase by 0.934. And that's kind of unitless because I described to you how that is measured. Okay, so that's the slope. What about r squared? What about the the coefficient of determination? Okay, let's see what that was. That was a 0.616. So we want to describe that. So we're trying to predict the teen birth rate. So the percent of children in poverty, the percent of children in poverty explains, and I'll fix this too, explains 61.6% of the variability in what we're trying to predict, the variability in teen birth rate. Okay, so let's read it back. The percent of children in poverty, that's what we're using as our predictor variable. That predictor variable explains 61% of what we are trying to predict, which is teen birth rate. So it's a pretty good predictor. How good a predictor is the percent of children in poverty? Pretty good predictor. It explains 61% of the variability in teen birth rate. There's only roughly 30% of the variability in teen birth rate that isn't explained by how the percent of children in poverty, explain it in a linear fashion. Okay, so that's a verbal explanation of what R is, what the coefficient of determination is. What else? We've got a couple of residuals. We've got this smallest residual, which is a minus 6.31, and that was New York. New York's teen birth rate which is what we're trying to predict, is, now it's negative, okay, it is 6.31 we'll just call it units, lower than other states with the same see if it kept it with the same percent of children in poverty. This should be states. Up. Okay. So you got to be really clear about this. You want to mention lower. We're going to use the word units because it's not a percent. I described what it is births per 100,000 per 1,000 females aged 15 to 19. So we'll just call it units. So New York's teen birth rate is negative 6.3 units lower than the states that have the same X value, namely percent of children in poverty. So I am going to save this eventually so that you can use it as a model. And I don't want to have any type-overs here. Okay. So that would be an explanation of the most negative residual. If we're ambitious enough to go for the positive one, 8.34, and that was Alaska. And we're going to use pretty much the same words. Alaska's teen birth rate is what have we got here? 8.34 units higher and then we can copy paste than states with the same percent of children in poverty. Now you want to understand that a low birth rate, the fact that it's a low birth rate, that's a good thing. So the birth rate in New York is basically lower than expected, and the birth rate in Alaska is higher than expected. So low birth rates are a good thing. High birth rates are not a good thing. So that puts things in a little bit of perspective. So this should have been the change in y divided by the change in x. Okay. So we explained what the slope is in context of the problem. What was the y, teen birth rate? What was the x, the predictor variable, percent of children in poverty? So as the percent of children in poverty go up by 1 unit, the teen birth rate goes up by 0.93%. So that ratio is close to 1, which is why the correlation coefficient was 0.78, and it was a really high correlation between these two variables. It was a moderately strong positive association. The coefficient of determination, what we're trying to predict, which is the percent of children in poverty, is explained. It explains 61.6% of the variability in birth rate. So again, 61% is a good percent of variability that's being explained by our predictor variable. New York's birth rate is 6.13 units. The birth rate is 6.13 units lower than states with the same percent of children in poverty. Conversely, Alaska's teen birth rate is 8.34 units higher than states with the same percent children in poverty. So I'm going to leave you with that. Maybe I'll put some separators here so that you'll know this is one thing. Oh, it's actually, I want to put that underneath the explanation. So that ends the discussion of the slope. Next comes the discussion of r squared. And next comes the discussion of the residuals. So we did a few things. We explained the slope. We explained the coefficient of determination. We explained each of the residuals, the most negative and the most positive. So I'm going to send you this document that I guess we can call interpretations. I'm going to save it. And send it to you. All right. So I hope this helped. I also showed you how to use StatCrunch to get simple linear regression output. Hope you enjoyed this video, and I'll send it all to you.